Welcome to BKW Physics. I'm Mr. McConley. Today we're going to talk about standing waves. Standing waves are kind of an odd phenomenon because it's like partially optical illusion and partially something that's really happening in physics. And basically what a standing wave is when you send some waves down a medium, a material, and they hit the other end, and then they reflect, and they kind of overlap one another, and the net effect is, sort of like the picture I have here, it looks to you like there's waves going up and going down all at the same time. It almost looks like this material, like if this is a slinky, we'll say, it looks like the slinky is here and here at the same time, here and here at the same time, and then there's spots that don't look like they're moving at all. So, you know that it can't be in two places at one time, so you know it's some sort of an optical illusion. Let's explain how it works. First of all, with a standing wave, one of the requirements is you have to have the same or a constant frequency. So it has to be rhythmic. The pulses of the waves have to be 1, 2, 1, 2, 1, 2. You have to bounce the wave off a rigid or a fixed end. So it needs to reflect off a fixed end. Now what's the logic there? Why do you have to reflect off a fixed end? What do you know about when a wave hits a fixed end? It reflects, but how does it reflect? On the opposite side. So when it reflects, when it bounces off the fixed end, it gets inverted. And that's key. It needs to get inverted so that it's a mirror image of itself. You gotta get the mirror image of itself, so you gotta invert it. And the other thing you need to get one of these standing waves is you have to have the same amplitude. So you can't be like big wave, small wave, big wave, small wave. It won't work. They have to be the same amplitude. They have to hit a fixed end and reflect back, and they have to be at a constant frequency. Well, let's look at this example over here. This is an example of this character right here is holding the slinky. He's making waves. 1, 2, 3, 4. It's attached to a tree over here. See the tree? Okay, there's the tree. And so the slinky is bouncing waves back and forth, and you're getting a standing wave. What is the amplitude of this? First of all, people get a little confused here, so let me clarify. If this is 20 centimeters, the amplitude is from the midpoint up or from the midpoint down, either way, 10 centimeters. How about the wavelength? Well, that's a harder question, a much harder question. The wavelength is, well, how many waves are represented here? So let's start at that point. If we can look and say, from here to there is one wavelength, lambda. And then from there to there is one wavelength, lambda. How much is left over? That looks about like a half a wavelength. Or it is a half a wavelength. So all told, how many wavelengths do we have in this picture? It's 2.5. How long is the total standing wave? So if you have a distance of 2.5 and 2.5 wavelengths, how long is each one? Yeah, the wavelength is 1 meter. Okay. Which the way we got that was taking the total distance divided by how many wavelengths we see here, giving us 1 meter. Now the last thing is sort of a vocab thing. A standing wave is consistent of nodes and antinodes. Nodes are when you have a point of no disturbance. For instance, I'll circle all the nodes in blue. Node, 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 node. So we got 1, 2, 3, 4, 5, 6 nodes. How many antinodes? Well, the antinodes are the points where the wave looks like it's at two places at the same time. So we got an antinode here, 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 5. So this picture has 6 nodes, 5 antinodes. And I think at this point we're going to spin around to the back of the room and we're going to make a standing wave on a snaky. Frank, my assistant, is going to hold the other end. And what I'm going to attempt to do, it's a little tricky, but I'm going to try to do a constant frequency, a constant amplitude, and you're going to be the fixed end, so you just have to remain steady. Okay? So here we go. Lost control a little bit there. We'll start again. Did you see the standing wave for a moment, though, before it went off the desk? Watch again. I don't really like that one. Oh, there we go. Right there, right there. I like that one. Can you see that in front of Meg? There's a point that's a node. It's not really moving. Whereas a little bit further down, right about at this point, right here, we had an antinode where it was swinging back and forth. Was that clear to see on the video? Now, a lot of times these standing waves happen at really high frequencies, which I don't think I can really do, but I'll try to do one that's a little quicker. I can get it there for a second, and I kind of run out of steam. So for today, standing waves.